Hey everybody, this is Larry. This is March 16th in the year 2025. And today we had a easy problem, so I'm going to try to do a bonus problem. Today just keep it medium. We're missing a lot of problems anyway. So yeah, let's do one that I haven't done yet, and let's keep it algo because I have a lot of SQL problems that haven't done yet, but you know, not that interesting for today. Okay, so today we have 3391, a premium problem. Design a 3D binary matrix with efficient layer tracking. Okay, so we're given an n by n by n binary 3D array matrix. Implement the matrix 3D class. Create set a cell. Okay, unset a cell. Largest matrix where matrix of x contains the most number of 1. What does matrix of x mean? Oh, as in like the as in okay, matrix of x meaning that the thing that contains y and z. Okay. Um I mean I don't know. Okay, I mean I don't think there's anything too tricky about this one. I think I'm just confused a little bit sometimes because the wording of some of these can be a little bit very specific. I think the key thing about these kind of problems, they're twofold, right? One is, despite all the flowery language about matrices and all these things, they are there to, I wouldn't say fool you, but they are there to seemingly complicate things without really complicating things, right? And one thing that I have sometimes been bad about, maybe not all the time, but sometimes, is that I bring my own experience into the problem, right? Which is maybe good for real software engineering stuff that inspires you to ask better questions or more in-depth questions or just questions in general and see where they lead. But for competitive programming, it's for interview. I think that's fine too, by the way. But for competitive programming, it sometimes you just carry around stuff with you that is not necessary to know, right? Um, for example, like there's an example that I always use. I think it's a Leetcode problem, but maybe it's a code force problem or something, some other thing where they talk about bowling. You know, the game where you bowl a ball and roll down the pins, right? Except for in that problem, they were like, oh, it's bowling, except for you have all these other rules that is not bowling. And it's like, well, actually, then it's just not bowling. It's just a ball game that, you know. So it's like, but, and then if you make assumptions based on the fact that you know how bowling works, like the rules and the game, the scoring and stuff, then you'll get it wrong because you made an assumption. And have had this happen numerous times in the past, which is why problem writers, please, no abstraction. But yeah, and kind of going along the same line is just do the minimal that will allow you to solve the problem, right? So okay, so what I mean by that, right? So it doesn't look like XY does anything really, right? Just to be frank, yeah. The only thing that I think I wouldn't call it an edge case, but special case is that you can set the a value multiple times. Otherwise, if you cannot, then you can just have a counter even, right? But because you can set multiple times, you just have to know whether it was previously set. And honestly, the Y and Z doesn't really matter in the sense that you could have just one key and it'll be fine. X is the only thing that matters. So yeah, so that's how we're gonna structure it, right? So then here maybe we can write, I don't know. I like to call everything lookup. I don't think that that's a great name, but yeah, but it's just this, right? And then what do we have? Maybe a set, right? Yeah, so this maps X to a YZ set, right? So set cell, maybe self.lookup of X, we add YZ, right? Something like that. I mean, I'm being really lazy here, but yeah. I think for set you could add and it's fine, right? But yeah, and then maybe I feel like in Python there is a remove that is safe, right? That doesn't actually remove, but I don't know. I don't know. But we can also clearly gate it very easily, right? So something like that. And the beauty of this is, of course, you can do the query, Oh no, I'm a little bit wrong, but in any case, yeah. So yeah, I thought it was going to be just return. For some reason, I forgot the part. But there are a couple of ways you can do this. Right now that you have these, and that's the minimal, then now you can update. Um, you can just update the x versus the number of ones mapping, right? So maybe you have a x to 1 or something like that. That's a terrible name. So maybe just x's, I don't know, is you go to collections.counter, right? And then here maybe stop.xs is equal to of x is equal to length of, and you don't even have to do anything, right? In the sense that you don't even have to like do anything tricky to maintain like increment or decrement. You just update that to length, and that's it, right? Here for the largest matrix, then of course you can go for the x's, and it turns out that there's only 100x, so maybe that's fine. I don't know. 10 to the 4th times 100, maybe that would have been fine. But you can also do a little bit better, right? You can use a heap, you can use a sorted list. I'm going to use a sorted list just because it's a little bit easier to update. With using a heap is also fine, but you have to be careful with lazy updates, right? Or you have to write your own heap. Either of them is also fine, but it's just things you have to consider, right? So maybe a h for heap, right? And it is I don't know, there are a couple of ways you can write this. Maybe just 0 or do I even need to do a heap actually? Yeah, maybe you do. The removal is a little bit tricky. But oh, I didn't want to use a heap anyway. I want to use a sorted list because I'm lazy, right? But yeah. And here, maybe we look up the previous is you go to so this is before the adding, right? So we get the key value where we have x previous, right? So then now we can remove x previous and or the other way around, the previous x, and then self dot add self dot xs of x and then x, right? So that it remains sorted. We also want to do it here, of course. Maybe we could put inside the if statement though. Pretty just to maintain the state. And then now the invariance after each of these functions set and unset is that the sorted list will contain the largest element in the end. Well, do we turn the index though? So with the largest x is also actually coincidentally what we need anyway. So yeah, I was initially going to say yeah, we can just return self.sl, the largest element, and then the first index of the largest element, which is the index. But we also I've messed this up a little bit in that we do have to add this, which is 0 I for I in range of n, right? I like big n's. Double check whether n is a 0 to 1 or a 0 index or 1 index, and it seems like a 0 index, so this should be good. Let's give it a quick run. 450. Oh well, no. Oh, here. This previous is equal to the length. Oh, this should be a tuple. In a lot of places they are interchangeable, but clearly not this one, which is a little bit sketch on my part. Okay, so clearly we have something wrong. So 0. That is weird, but okay, let's see. Do I not? Okay, so after the first one, we set. Okay, and this looks reasonable, but then after unset, we don't do it. Do we not? Oh, this is a typo. Oops. Okay, I mean that's an annoying typo actually, but easy fix obviously. Very scary actually, typo. Hopefully I don't have another one. Looks okay. I mean, a little bit slower, but I'm not really that worried about it. Complexity is fine-ish. Right, so on add and unset, this just have remove and remove. That's going to be the most expensive part, is add and remove on the sorted list, which is log n. N is not that big, but I guess the constant cost is a little bit high. And this is, I think, all. I don't know if this is all of 1 or all of log n in sorted list. Because for the biggest element, you can say that some data structure might have had it pre-cached or something, or pre-set up, but unclear. Yeah, I mean, I think that's all I have. Can I do this a little bit faster, given that this is log n? I mean, increasing should be easy to do. It is just that when you remove, then it decrements by 1. Then you have to get the previous max. I mean, so yeah, so you can actually have like I feel like there is a thing for it. I mean, you can definitely do it with like a skip list type thing, or is it called skip list? I don't know if it's called skip list. I mean, there is a skip list a thing, but I don't know that that's what I'm thinking of. Because basically you have like you can think of it as just having buckets or something, right? So I mean, actually, yeah, you can. You can do it without a list too, right? You can just keep track of like almost like a bucket sort situation, right? Because, but that seems it in my head is very complicated, but it's actually probably not that bad once you do it once. But the idea is just that you keep track of max, and keeping track of max when you add stuff is easy, right? Because if it goes over, then you just keep doing. But it is the subtracting stuff that is hard. And what you can do is just keep track of the count, right? So you have a yeah, maybe like a bucket of things that goes like, for example, if you go from 9 to 8, right, after you subtract, well, are there other stuff that's in 9, right? If there's stuff that's in 9, then they become the new max, right? And if you subtract stuff from 8 to 7, then also the 9 would still keep on, for example, and you would just basically have a sparse array of use basically an array, but using a lookup table map that kind of keeps track of the value as the key. I don't know if that makes sense, but I don't know, it's really complicated, and I don't know. Maybe that's fine for today. Anyway, that is all I have now. That's all I have for this part. Let me know what you think. Thanks for watching, and yeah, have a great week, everybody. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.